All right, so we'll go ahead and kick off Trek 2 over here. So today with us we have Aranguren with 7A Security. So today he's going to be talking to us about practical mobile app attacks by example. So we'll kick it off to Abraham.
Thank you. So yeah, I apologize in advance because I have 210 slides and 9 demos. So I'm going to fly through this pretty quick. But there's a slower version of this that is a 4-hour workshop. There's like, you don't have to pay or anything, it's free. And you can just go to 7asecurity.com/free and you can get all the slides and download the apps and a lot of the things that I'm going to explain today from there, right? So that gives you access not only to the talk, but also to the vulnerable applications that I will be talking about today, at least some of them, right? So yeah, and another thing, since we have some university students here, I'm the founder and the project and one of the project leaders of OWTF, which is an OWASP flagship project. So in the summer, there's a program by Google called the Google Summer of Code. So if any of you is interested in participating in the Google Summer of Code, you basically get paid by Google for coding for some open source projects. So the OWASP Foundation has a number of projects, and one of them is OWTF. So whether you are interested in OWTF or not, you can just go to owtf.org and that takes you to the OWASP page of this project, but there's also other OWASP projects you can contribute to while you get paid for it, right? So win-win. So just a brief mention of that. So I'm Aranguren, I'm the CEO of 7A Security. We do pen test and security training. So there's a lot of public pen test reports in publications. I'll talk about this like in a second. I'm the co-author of our mobile, web, and desktop, which is basically Electron applications, security courses that we have, and that's explained on the training page. We teach these courses all over the world, and I'll be teaching the web hacking class here at DakotaCon on Saturday and Sunday. So if anybody is interested, maybe you can still make it. So we've done training at Black Hat, Hacking the Box, OWASP Global AppSec, and many other conferences. I tend to go to LASCON. I think the last maybe 4 or 5 years I was at LASCON in Austin, Texas as well. And I was also here last year for DakotaCon. Last year I was teaching the mobile security class, and this weekend I'll be teaching the web hacking class, right? So yeah, this is what I said before. Like, I'm the founder and one of the project leaders for OWTF, which is an OWASP flagship project about web security. If you type owtf.org in your browser, that takes you to the OWASP page of the project. And with Google Summer of Code, you can get paid for contributing either to this OWASP project or any other OWASP project that you are interested in. This is my slideshow for some presentations. And then I was a developer first, and then I switched to security, and my employer was paying for most of these certifications, so this explains how I took advantage of that. But basically, if you are a developer or you are a security person, I got your back, right? So I know the pressure of developers, like it has to be in production on Friday, I don't care how you do it. And I'm also fully aware of the frustration of security people when their vulnerabilities are not getting fixed, right? So I understand both sides of the story. And yeah, about the public pen test reports, right? So a lot of the vulnerabilities that I'm going to show today are from public pen test reports. And public pen test reports are really interesting because no matter which company publishes them, it's a very easy way to learn about security, right? Like what vulnerabilities are being found in the real world on real applications. And you can just go to 7asecurity.com/publications and you just click on any of these. You don't have to register anything. You get the PDF, full report, and you can see, hey, what kind of vulnerabilities are being found in this project that has like proxy APIs, or in this project that has mobile apps, or this project that has like AWS, right? So you can see kind of more or less what was tested in each of the tests, or I'm interested in threat models, right? So what are these threat models like? So you have threat model, another threat model here, right? Or I'm interested in supply chain, so what is being found in the supply chain, right? So you can just click on any report and learn about that, right? Now, since this talk is about mobile application security, you also have like the word mobile in some of our public pen test reports, and then you can learn about those there, right? But basically, it's a very good way to learn about security. And from here, maybe I highlight like a couple. So some of these projects here, we found CVEs in Linux Foundation projects, like Linkerd, and in Logback, you might recall the Log4Shell vulnerability, so we also found like some CVEs on this. Libuscares is also like a Linux Foundation project. So we've done work for the Linux Foundation, for the Mozilla Foundation. We are working on a pen test for the Mozilla Foundation again this month, and we will be testing the Linux Foundation later this year. Right now, K9 Mail is going to be the new Thunderbird for Android, and we also tested this for the Mozilla Foundation. And then some of the vulnerabilities I'll be talking about today are from the Live Home Safe mobile apps that were kind of mandated in Hong Kong. Basically, it was a COVID-19 contact tracing app enforced in Hong Kong. You had to scan a code everywhere, right? But I'll talk about it like a little bit later on in this presentation. So some interesting prior work would be like Live Home Safe, this COVID-19 contact tracing app that I'll be talking about. We will also see interesting vulnerabilities from Smart Sheriff. And then we also tested some Chinese police apps that were being used either by police officers in China or installing people when they were crossing the border and stuff like that, right? So you can watch the prior presentations and stuff like that over there. So today, we will be talking about some interesting attacks in mobile application security, right? So what happens if you have excesses in a mobile app? Can a mobile app have a local server? What can go wrong if a mobile app has deep links? Then we will see an interesting case from a real pen test where a deep link led to SQL injection, which also led to remote code execution, which was pretty cool. And then some crypto fail and other interesting stuff with mobile API opponents, right? Because the mobile application, you shouldn't just test the mobile app, you also should test the API, right? Normally, if you hack the mobile app, you hack one user, but if you hack the API, you might hack all of them, right? So I'll be talking about all this. Again, I'm sorry I'll have to fly through this because I have so much content, but I'll be explaining a lot of these things through demos as well, which will, I think, make it more practical and useful for you if you want to apply any of this. I just like to make talks practical, right? So with now in this first section, I'm going to talk about attacking web views, but a specific scenario where the web view is misconfigured in a way that it allows you to do data exfiltration from the mobile device, right? So this can happen in Android and iOS. So let's see first how this works on Android, right? So there's some attack requirements, right? So the web view needs to allow JavaScript and other things, but I'll be talking about this in a second, right? So when you have a web view, you could have XSS or you could also have HTML injection. Now, HTML injection, now if you are pen tester at the beginning, this might be a little bit of a bummer, right? Like, oh, if I can inject HTML, but I don't have XSS, right? So it can be frustrating, but in the context of a mobile application, you have to bear in mind, like, mobile devices are small. They have like a small screen. They don't show the URL to the user. So even if you only have HTML injection, if it is a good HTML injection, good enough for you to alter the entire page, and the URL is not shown, then this could be catastrophic, right? Because you can basically spoof the page and have like a fake login form that looks exactly like the original mobile app login form, but is going to send the credentials to the attacker-controlled server, right? So don't underestimate HTML injection in the context of mobile security, right? But of course, it's much more interesting if you have XSS plus the ability to do data exfiltration. So this would be like the web dream, the web dream of a mobile pen tester. And then you also could have even possibilities to do cross-site request forgery from the XSS as well, right? So for this exercise, now of course we cannot, attack like a real app for this. So I'm just illustrating the steps for this. We will use like a modified version of Androgo. This is like in the training portal. Like if anybody goes to the 70security.com/free, you can download this app that we modified in a specific way so that we could do this exercise. And basically, we first have to save some data. So we create like some preference file that is going to store some credentials in disk. Also the same with a SQLite file, right? So we are basically storing credentials in plain text in the file system to demonstrate the XSS later. And then you go here to the XSS, and then the steps are usually something like this, right? So first you inject something like, you know, some HTML tags, and then you can see that you have like a bigger hello, so this is already interesting. Then the next step is, okay, can I turn this into an actual XSS, right? Can I execute JavaScript? So you normally do that with an alert. Now sometimes there's some filtering and an alert doesn't work, but prompt works, right? So always be a little bit creative and try not just alert, but try prompt and other approaches as well with JavaScript, right? So now we have the alert, so this proves that we can execute JavaScript, and now the question is, well, what can we do with this XSS, right? So the next question for data exfiltration purposes is, what is the security context in which this XSS is working? And that question is going to be answered by the value of the location, right? That what is the URL that this web view is being loaded from, right? So if the URL is a file URL, you should get excited, because this means that the web view has file access, right? And if you have file access and it's, you know, like the web view is being run from a file URL, then we could probably exfiltrate data, right? So in this case, we have internal storage and external storage, right? So this is like in the modified version of the app to illustrate this. And yeah, so there's like two scenarios, right? So if you do ADB shell, so this gives you like a shell in the mobile device, and then you CD here, and then you can see like the user's XML, and this is like the SQLite file that we populated earlier. And then you can start like sending XML HTTP requests from the XSS to demonstrate that you can access local files, right? So you can read this user's XML, you can read the SQLite database, and you could, like in a real attack, you would send this to an attacker-controlled server, right? So this illustrates that this works, and I'll show like the demo in a second. And then you could also even read files from other places in the mobile device, right? So this was tested on a Xiaomi device. So you can, for example, read configuration files from the actual Android device. So as long as the application that is vulnerable to XSS has permissions to read a file, you can read this file and its contents, right? So this is illustrating that. And then basically this is the methodology, right? So can we execute JavaScript? What is the security context, right? So you normally demonstrate an XSS like in the same way as you would in a web application with an alert normally, then with the location, what is the security context? And then you can start sending XML HTTP requests to read local files and then send them to an attacker, right? So now this, I said at the beginning that this attack, well, it used to work like in old Android and iOS versions by default, but then, of course, with time, Android and iOS got better. So now a developer would have to shoot themselves in the foot to enable all these things, right? But sometimes it's done, right? So it's still a possible attack nowadays, just a little bit less common, but because it's not the default, right? So you need to have JavaScript enabled, you need to have the ability to load file URLs and so on, right? So this is why the attack is working, basically. And yeah, let's do the demo so that you can see it in action, and then maybe it will make more sense, right? So there's internal storage and external storage, right? So the internal storage is protected by Android, so other apps would not be able to read it, and then the external storage would be the SD card. So the SD card is really dangerous in Android. I'll be talking about this a little bit later on as I showcase other vulnerabilities, because the SD card can be extracted without knowing the PIN of the user, right? So you can see here now that we can read like all these different files, and we can even read files from other apps as long as the permissions allow the vulnerable app to access them, right? Yeah, so basically this is how this attack works. And yeah, and then of course this is also possible in iOS. Actually in iOS this was possible by default for way longer, because web views in iOS, the old ones, the UI web view, were vulnerable by default to this type of attack. So in this case, we will use the Done Vulnerable Insecure version 2, and you just follow these steps here, and you go to the web view issues, and it's the same methodology, right? So first you inject some HTML, you see like a bigger hello, so you get excited that you at least have HTML injection, and then the same steps, right? So can I alert one, what is the location, and then you start reading files from the device and see if you can retrieve them, right? And if you can, then it's because it's vulnerable, right? So this is what the steps would look like. So alert one. Then in iOS, you can have two cases, right? You could also have a file URL, but you could also have like Apple Web Data. It's basically the same thing. Both allow you to read files from the file system, right? And in here you can see that we can read the data, and basically it's the same thing, right? So now this is the code that was vulnerable to this. So you can see there's a string concatenation here. So the attack in iOS requires two things, right? So you need a UI web view. The UI web view has to be vulnerable to XSS somewhere, right? So you will have some string concatenation of user input into a string. So this is the string concatenation. And then the other requirement for this attack, you would have to have like a base URL of nil or a base URL of file something, right? So in both cases, if you have file something, it will be a file URL, so same thing as Android. If you have base URL set to nil, then basically web UI web views will default to Apple Web Data, and then this gives you the file access, right? So base URL set to nil on a UI web view, bad idea, right? And yeah, then this is possible because of these settings that were turned on by default on UI web views, which is what I was saying before. But in WK web views, this is like not vulnerable by default anymore. So in general, if you're an iOS developer, you know anybody developing in iOS, they should use the WK web views, which are safer by default and so on. But you could still have a WK web view that sets these things incorrectly to allow file access, and then you could still have the same problem, right? It's just not vulnerable by default. So yeah, so let's do like a quick demo about this to show that data exfiltration with iOS is also possible. Now again, it's the same process, right? So alert one, we have XSS, alert location, what is the security context in which this web view is running. And we have Apple Web Data in here. So this means we should have file access. And then from there, you start trying to read local files, right? So you start doing XML HTTP requests to retrieve like arbitrary files from the device, and as long as the application has permissions, you should be able to read them, right? So I'll just show an example of that. And then you can see we have file access, right, with this vulnerability. Now let's see some attacks on the SD card, right? So I briefly touched on this, because in the SD card in Android, this is like a dangerous place, right? It's the Wild West of Android, because many applications can read and write there, not only in the directory of the app, but anywhere on the SD card. So if you save anything sensitive on the SD card, any other app on the device can read it, so this is already bad. But another very bad thing is that it can be extracted without unlocking the device, right? So if you have an application that saves sensitive data on the SD card and someone loses the phone, or drops it in a toilet or whatever, and someone extracts the SD card from this phone, they can plug the SD card into a computer, and then they can read everything, right? So, and there's also like no encryption by default on the SD card, right? So this is why it's bad, right? So let's see some attacks on this, right? So in this case, this was an application that was in one of these like human rights activist countries where they develop an app to allow people to report human rights violations going on by police and the corrupt government and so on in this African country. And basically, they were storing these human rights violations on the SD card. So what could happen with this, right? So you have the device and so on, the phone number, first name, last name, age, gender, marital status, address, you know, like basically like everything, right? So with this, it's already really bad, right? Because this is in the SD card. So in a country like that, you could have someone who is trying to do a good job and reporting all these human rights violations going on, but then a police officer catches you there and extras the SD card and sees like, oh, you're this guy that is reporting on these human rights violations, and then maybe you go to prison or you are tortured or whatever, right? So it could be like really bad in the real world. So let's see this persistent XSS and data exfiltration scenario, right? So you load this from the SD card, it's stored in a variable, and it's concatenated into HTML, so we have XSS, right? So this is the vulnerable code. So there was a chapter txt file loaded from the SD card, then it's stored in a variable called page data, and then page data is concatenated as a string. Normally, string concatenations is what you should always look for lots of vulnerabilities like SQL injection, XSS, and many other HTML, XML injection, right? So lots of injections are possible because of string concatenations, right? So you can see here that we have XSS, and then in this case, we had to encode the payload. So for this, Hack Vector is a really useful tool. You can even use it from your browser. There's also like a burp plugin to use it. It's called hackvector.co.uk. It's a website. It's by Gareth Hayes, who is now a researcher at Portstrigger, the company behind burp. And basically, you put the whatever XSS payload you have, and then there's like different encoding mechanisms. One is eval from car code. And then what this does is if it doesn't have like any single or double quotes anywhere, right? So it gives you equivalent JavaScript, but without single or double quotes anywhere. And this allows you to run XSS in scenarios where a web application, or in this case, a mobile application, has trouble because it's like so broken that if you have like a single quote, for example, the website or the mobile app would be broken, right? So you can encode it with it, and then this was the encoded payload, and then you could like read local files, right? So we have permanent XSS or persistent XSS with data exfiltration, right? So it's persistent because it could be persisted in the SD card, right? So you could modify the chapter text file that I talked about. So this is why it's persistent, right? So it's like stored XSS on a web application. Now, another interesting scenario in mobile applications is spoofing attacks, right? Where you show something, but the user is really going to do something else. For example, you show one URL, but then the user clicks on it and they go somewhere else. So sometimes you can do this with Unicode, left to right and right to left characters. So this comes from the legacy complexity of languages, right? So at the beginning, there was just the ASCII code where only English was assumed as being the only language. Then there was this extended ASCII, and then there was Unicode and so on, because of course there's people like in other parts of the world that don't use English, right? And they have like Japanese characters, you know, Chinese characters, Arabic characters, Russian characters, right? So because of all of this complexity, you have sometimes interesting attack vectors using this, right, historically. So for example, you can use this Unicode left to right and right to left characters, so you could send a link like mock.evil.org, and then the victim sees grow.live.com, but then when they click on it, they really go to mock.evil.org, just because you are messing with these characters, right? So this can be useful in email apps or chat applications, right? So any application that is going to show the user input of user A to user B, right? So whenever you have this type of flow, this type of attack could be interesting. And then very interesting attack vector on mobile apps is a local server, right? Because like normally nobody thinks about this, right? Why would a mobile app have a local server, right? But sometimes it's done, right? So we've seen it in real pen tests. And then if you have a local server, you could have a lot of problems, right? So what interface is the local server listening? If it's listening on the same IP as you are on open Wi-Fi, then anybody on the open Wi-Fi could attack you, right? So this could be one problem. Then another problem is that other apps could also like attack whatever server is in there. And then another problem is that if you have a local server, now you have to worry about authentication and authorization, right? So what does the server do? Should, you know, be anybody like allowed to do actions on this server and so on, right? So this was a Cordova iOS app where it was using a plugin that was running a local server, and then the local server had a path traversal vulnerability, so you could do like localhost and then using the // sequence and read like local files like etc password and so on, right? So you could do this like from any website that the user is visiting, right? So you visit an attacker website and then the attacker website can do like stuff like this, right? So this was demonstrated like this, but then like a local app on the device would also like have more potential, right, to exploit this. So you can read like local files that the app can read. So here we are reading etc password, and you could also read like files that the app has, right? And then like you could simulate this with a shell one-liner from the iOS device. So this is like a for loop, and it's just retrieving all the files using the local server and then just dumping them in the system, right? All this being said, now I'm going to talk a different type of attack vector. So does cross-site request forgery exist in mobile apps? Anybody? Yes, no, maybe? Yes, we have a yes over there. So yes, so normally cross-site request forgery is achieved in mobile apps using deep links, right? So we're going to see a couple of scenarios where deep link attacks achieve user impersonation and then to bypass authorization controls, right? So you could have normally like mobile apps will define like some URL like this, like social app, homepage, profile picture, and so on, right? So there's different URLs. And then in Android, you are especially interested in activities that are browsable, right? So browsable means that it can be attacked not just from the mobile device, but also from the browser, right? So you could remember it maybe like that, right? Browser, browsable, right? So if it's browsable, it can be attacked from the browser as well, right? And then this is called an intent filter, right? So you can see here intent filter. So when you see intent filter, this also means this activity can be attacked by any other application running on the same device, right? So whenever there's an intent filter, this is the equivalent of an open port in network security, right? So if there's an open port, you can attack it. If there's an intent filter, you can attack it, right? And then these intent filters normally have some rules, right? So you can have like a scheme, a host, and a path prefix that is required, and so on, right? So this is normally the stuff you look for to attack this type of stuff. So for this exercise, we will use like a vulnerable version of Periscope, which is like available like, again, if you go to 7secure.com/free and you go to this workshop, you can download the slides, and from there, there's the Periscope APK that is vulnerable to this. So you can follow these steps. And then basically the idea here is that you create a new account, and then you check the Android manifest, you look for these browsable activities, and there's one that has a scheme of PSCP with a host of user. So this is telling us the structure of the deep link, right? So PSCP user, and then the ID of the user, right? So this is going to show the user. There's no attack yet. This is just how the deep link works. You can use this with ADB shell, which would be my preferred way to talk to developers and for pen test reports, so that the steps are more easy to replicate for an Android developer, because they are not going to have any hacking tool installed. But you could also do it with Drowser, right? And now Drowser also has a scanner, which is not very good, but it will give you some results. So you could also run the scanner and it will give you some results, right? So in this case, you have the PSCP URL in there. So to exploit this, there's a few ways, right? So what we want to do is to follow an arbitrary user. So we want to make the application follow an arbitrary user, right? With this deep link attack, which is basically a cross-site request forgery, right? So there's a few ways. One is with deep link tester. So deep link tester is an application that you can use, and it's basically going to to try to access a URL, and then this will send a request to the vulnerable app that handles this URL. So if you put the URL in there and you click on it, then you could see like the user is loaded, and then you start following it without any sort of confirmation from the user, right? Which would be the way to fix it. You could also do this with ADB shell, so you can do ADB shell, and then you send the deep link like this, and then this is like a follow to an arbitrary user, and you could also do it with Drowser. Now, ADB commands would be preferred in a pentest report. And then, because the activity is browsable, we can also do this attack from a browser, right? So there's a demo page here that you can use for this, and then basically in here, you just click on the link, and it will also open the app and start following the user, right? So this is what the HTML of that proof of concept page looks like. So this is just opening the profile of the user, and this is the problem, right? This is the cross-site request forgery that you can basically follow any arbitrary user using this. So let's do a quick demo about this. So this is the opening the profile of the user. So here we have PSCP, and now we are doing the follow, and then you go to URL, and you saw like this change to following. So we are basically making the app follow any random user we want without the explicit consent of the user, right? Then another scenario would be to do this with ADB shell, right? So you can go into the command line, and then you basically have to just removing the space there, and then you have to first, it's a little bit tricky because you have to first unfollow, and then you also have to add the quotes, or remove the quotes, and then you can see here that this changed to following, and then you can also do this with Drowser, right? The Drowser is basically an application that is simulating a malicious application installed on the device. So this would be the Drowser command to do the same thing, right? So it's different ways of doing the same thing, right, basically. So, okay, so with that, now let's do this more interesting, right? So there's other approaches, right? So you could also have a deep link attack that makes a phone call, right? Because like if you're a criminal, you want to monetize the attack, right? So you want to not just make the app open like random links, but you also want to make money, right? So if you make the application make arbitrary phone calls, you can call a premium phone number that you're going to get paid if they call it, and then you can make money that way, right? So for this scenario, we will use like iOS and the non-vulnerable insecure app. And then in this case, what you're looking for is in the info plist, right? So this is in iOS the equivalent of the Android manifest. You're looking for URL schemes. So we have a couple here. So this is telling us about the structure of the deep link. Another way, if you have the source code, would be to go into Xcode, and then you open the project and go to info, and here you would also have the URL schemes in there, right? So this tells you how the deep links start. So this means the deep links are going to start with non-vulnerable insecure app Swift or non-vulnerable insecure app : right? So one of the two will work. And then the code that is going to handle the deep link should be called from the app delegate, right? So in this case, this is a Swift application, which is very common nowadays. So you want to find where the app delegate is, right? If you have the source code, if not, you will have to use reverse engineering for this. And this is the vulnerable code, right? So it's basically, there's an application function, and then it's basically here like splitting the URL based on phone call number, and then it assumes the URL is valid if this cast to integer works, and then it will basically do the phone call, right? And this is the code in Xcode of the same thing, the app delegate and the vulnerable function. So let's just show the demo, right? And of course, you could also do this from an attacker website. So you can have, like if the victim navigates to an attacker-controlled website, the attacker-controlled website can also invoke the deep links from there, right? So this is what the URLs look like. Now, in a real attack, you would not show the URL. You would show, click here to win an iPad or something like that, something enticing for the user, right? But this is for demonstration purposes, so you would click on this, and then the only warning you get from iOS is like opening this app, and then if you do open, then the phone call would be made, right? So let's show a quick demo about that, so you see it in practice. Basically, you have an attacker-controlled web application, and then this web application has the links that are attacking the deep link, right? So then Safari will prompt you to open the vulnerable app, and you can see that it worked, that it made the phone call, right? So this is interesting because now I'm going to show like other attacks like related to this, and now you have the foundation to understand what I'm going to talk about now from other attacks from the field, right? So now let's see like other interesting twists from the field on vulnerabilities like this, right? So we have a URL, right, that is sent to a browser, right? So this is a browser application, so the browser application by definition has to take URLs because it allows people to navigate to URLs, right? So there's an application with an exported activity, right? Now, I already kind of mentioned this, but an exported activity means exported, it means it can be attacked, and you know it can be attacked because it will have an intent filter or it will have exported set to true, one of the two. But if it has an intent filter, basically it can be attacked, right? So this was the browser activity with an intent filter, so any malicious application on the device can call this. And then there was an intent extra processing, so it was looking for this query parameter and then getting it in there and so on. So what we are doing here is we're sending a deep link that goes to the SD card, and then we can steal the databases, right? So this is kind of similar to the data exfiltration that I showed before. But in this case, what we are doing is a malicious app on the same device, also with SD card permissions, can craft an HTML, any arbitrary HTML page on the SD card, and any other app with SD card permissions will be able to read it, right? And then this was the URL validation of this browser application. It had this regular expression. Now there's this famous saying, I don't remember the person who said it, I think it was O'Reilly, who said like, people have a problem, and then they use a regular expression, and then they have two problems, right? So this is one of those cases. So you can see here there's a regular expression, but it's allowing file URLs. And we already saw if you allow file URLs, you could be in trouble, right? So let's see. So you have a malicious application that sets a URL of SD card steal.html, and then it's invoking the vulnerable app to load this URL, which will be accepted because of the validation we saw before. And then when this HTML file is opened, then we loop through the databases of this application, and using XSS, we can have like data exfiltration, right? So we can start reading files on the data directory, which is protected by Android, right? So the malicious app can read anything on the SD card, but it cannot read data on the data directory. However, the vulnerable application can. Therefore, if the vulnerable application will open this HTML and execute whatever JavaScript is in there, we can just loop and retrieve all the files that this application can read. So this allowed us to read all the databases and so on, right? So now let's see another twist of this, right? So this is a browser application that goes to an attacker website that then exploits the deep link, right? So this was when we tested the Onion browser a while ago. So you could have image source of Onion browser force quit, and then the browser would quit, right? So you can have a website that is going to make the application close itself, right? For example, right? So whatever the deep link does, you should be careful that like whatever you load in the HTML is not able to access the deep link, right? And then this was the code that allowed this to happen, right? So yeah, and then another interesting scenario, now this is the ninja scenario, is a deep link leading to SQL injection, leading to remote code execution, right? So let's see, and this was actually in a commercial pen test, so it was an interesting scenario in a real app. So sometimes mobile applications will have a pop-up if the user is not logged in, right? In this case, it was a pop-up to log in with Google. And then when the pop-up is closed, it sends a deep link to the app with the authentication from Google, and then the app uses this Google token from their own, right? So can anybody tell me what the vulnerability is here? Any takers? Louder? SQL injection, very good. So yeah, we have, so I already kind of hinted about this before. When you have string concatenations, this is a good place to look for security problems, right? So in this case, we have a SQL query with a very clear string concatenation adding the value that comes from the deep link. We also have a browsable activity in the vulnerable app, right? So let's break this down, right? So what we do here is we create a bad binary as a proof of concept. So you can go to cd data just trust me, just any random app. Then you create a .so file, which is basically a library in Linux. Now Android works on top of Linux, so this works. And then even though it's the data directory, any app can give like insecure permissions to the binary, so any app can read it. Now 777 is excessive, you could do 755, doesn't matter. What matters is that, you know, like for demonstration purposes, who cares? But what matters is that you're allowing other apps to read this binary, right? And then what we do is we do ADB shell, and then we call the vulnerable activity with this deep link that is exploiting the SQL injection, right? So we're doing where select load extension of data just trust me test, and then the .so will be added by SQL Cipher or SQLite. And then basically we exploiting the SQL injection in a way that is loading a binary from the attacker app, and therefore this is remote code execution, right? So a SQL injection turned into remote code execution, which is proven by this message in the logcat logs, right? So you can see SQL Cipher database, SQLite exception, DL open failed, has bad elf magic, right? So it's looking for the magic bytes in the binary, but it's basically trying to load it. And here you can see the resulting vulnerable SQL statement, right? So what we're doing is we are closing the single quote, and then we do where 1 equals select load extension, and then we do data just trust me test, then the .so will be added by SQLite, and this is basically loading the extension and giving us remote code execution, right? So this was a very cool attack. And then because the activity was browsable, it could also be attacked from the browser, right? So this is the attacker demo, right? So you have like for example, a PHP script that is basically sending the attachment of test.so, and then it's just doing like 40 A's, just any whatever, right? And then this will create a test.so file in the download folder, right? So this works by default on versions of Android lower than 6. And then what you do as the attacker is you create another page that has the payload, right? So where 1 select load extension of SD card download test, and then the .so will be added by SQLite. And then first you load the test.so into the download folder, right? So you put the iframe that is going to load the binary, and then in another iframe, you just wait 5 seconds, so there's enough time for this to download, and then you attack the deep link, right? So you do this document get element by ID trigger, and then you set the source to the deep link, right? So vulnerable app, and then the data exploiting like the payload here, and then this resulted in the same thing, has bad elf magic, and in this case we have like trying to load the extension from the SD card, right? So we have a deep link attack with SQL injection, which leads to remote code execution, right? So now let's see some examples of URL validation. Now in this case, this was the Onion browser, which has the problem of when you load a .onion domain, it's not going to have a valid certificate, and therefore it should ignore SSL errors. However, there's a problem with this, right? So this allows us to ignore all the warnings, and it's just looking for .onion somewhere in the URL. So you could have paypal.com.onion.something else pointing to a Google IP address, right? So it's going to show a certificate for Google instead of PayPal or whatever else. So a normal browser is going to show you security warnings as expected, but the Onion browser didn't show any warnings because it had .onion in it, right? So it was a bug because it was looking for .onion somewhere in the URL, whereas it should be looking at .onion at the end of the URL, right? So this type of vulnerability is like a validation issue, input validation issue related to looking for the string anywhere in the string as opposed to at the end or at the beginning, right? So when you do code reviews, normally this is going to happen when you have includes, contains, string, or something like that, depends on the language in which the application is written, but that will be the case, right? Then another scenario for man in the middle is XMPP. So this is a protocol for chat applications like Facebook chat and others, right? So when you're trying to man in the middle, as the man in the middle attacker, like XMPP is kind of a crappy protocol that has this like star TLS thing at the beginning, but if you are the man in the middle, you can say, hey, I'm the server, and the only mechanism I allow to authenticate is plain, so you have to give me your credentials. Normally there would be a challenge response mechanism, right? But you can say as the server that you only accept plain, and then the mobile app send the credentials in clear text, which normally wouldn't happen, right? And then when you base64 decode this, you have the username and the password, right? So now another attack was attacking updaters, right? So in this case, the request was over clear text HTTP, loading a JSON file that had the ability to make it a forced update. And then the URL, you could put like, for example, like a phone number. And then when the user gets a prompt like a new version is available and then type on update, it will call a premium phone call, right? Similar to this would be a third-party zip file retrieval. In this case, this was on iOS. And one thing to look for when you're doing pen test of mobile apps would be to look at the info list and look for any app transport security exceptions, right? So since iOS 9, clear text HTTP is forbidden by default. However, iOS developers can go into the info list and create exceptions, right? So you can create an exception domain, which is going to allow insecure clear text HTTP loads, right? So always look for this, because if they set up an exception, chances are the application is doing something insecurely, right? And here you will have the hint on the domain where that insecure thing is being done, right? So in this case, what was being done is that this zip file was being loaded from an S3 bucket over clear text HTTP. So an attacker who has like man-in-the-middle capabilities, for example, Open Wi-Fi, could replace the zip file, and then the attacker can overwrite arbitrary app files on the device, right? Now let's see some crypto apps. Can anybody see the problem here? Give you 10 seconds. Give you a hint. What's the problem with this? When you create files based on the original file name that the user is giving you. Doesn't that look dangerous? Create files with whatever input you are given? Yeah? So that's basically the problem, right? So it was a crypto app, right? So you could encrypt a message with an original file name of, lots of slashes and then dot slash something else. And then when user B receives and decrypts this file, then the file will basically overwrite whatever you want, right? So you can go, you can overwrite like the database of the app or whatever, right? So user A can create and overwrite any file in the app storage, right? Now, another interesting vulnerability also related to mobile apps. This was a mobile app doing PGP for iOS. Can anybody see the problem with this? Hint, string concatenation. So it's an email app, it's doing PGP, and what does PGP do? It encrypts emails, right? So what is user input? The text of the email, right? So the text of the email is here, right? So the message, it said string escape for JavaScript, but it wasn't really escape. So this is the vulnerability, right? So it's basically loading the message, doing a string concatenation of whatever email you were being sent. So you could send basically someone an email with single quote, semicolon, your XSS, and then some valid JavaScript to close it off at the beginning, and then the JavaScript of the web view had the private key, the passphrase, and then the message. When it was concatenated, you basically closing here the single quote, then you have any XSS you want, and then because the passphrase has been defined just above, you can just load the passphrase variable and send it to an attacker, right? So you could send someone an email and get their private key and the passphrase and send it to an attacker-controlled server, right? Doing this, which was pretty cool, right? Just send an email to someone, and then you get the private key and the passphrase, right? And then, yeah, then you can just simulate like attacker server and retrieve the passphrase like that. Okay, so let's see a few more examples. Now let's talk about Smart Sheriff, right? So Smart Sheriff was an application that was mandated in South Korea. This is the good Korea, not the other one. And and in this place, they mandated an app to protect the children, right? Thinking that it would be a good idea for parents to control during what times of the day the children can use the phone, what applications they can have installed, during what websites they could visit, stuff like that, right? So it was mandated by law, and then we were asked to review it, and we found lots of problems, right? So in the first pen test, we found they were not using SSL for anything, so it was all clear text HTTP, so any attacker, like on public Wi-Fi, could intercept everything, right? Then in the second time we tested them, right, because this was like the report was sent to them, they supposedly fixed it, and then we did like a second audit, and they seem to be using like, you know, HTTPS everywhere, so we were like, hey, did they really fix it? But this was the SSL validation. So can anybody see the problem with this? So Android allows you to overload the unreceived SSL error event, and also it allows you to implement a hostname verifier. So in this case, all the code for unreceived SSL error was perceived. So this is the equivalent of a user clicking through browser warnings, like when, you know, Chrome says this page is insecure, you do yes, I want to see it anyway. So this is the equivalent. And then the hostname verifier was returned true, right? I'll show like a second vulnerability on this, right? So this was one problem. Then they also had a hard-coded XOR key in the application for doing some crypto. So you had the phone number, and then it was doing all these like XOR crypto. Right now, XOR can be good if the key is secret, but the key was not secret because it was hard-coded in the app. So anybody could download the app from Google Play and get the key, and then you can decrypt everything, right? So we created a script using this hard-coded key to do all this encryption and decryption. And this is basically how it worked, right? So this was the key, and then you have the XOR encrypted thing, and then it was run through XOR, and then this is like the phone number, right? And then in the second version, they implemented AES encryption as well of the entire JSON message, but the AES key was also hard-coded in the application, and this was the code, right? So it's just getting the bytes from an XML file, and just like AES like, is a good encryption algorithm, right? But the key has to be secret because it's like symmetric encryption, right? So because the key was hard-coded in the app, anybody can go to Google Play and get the key, and then everybody can decrypt everything, right? So this was kind of a summary of the security of this app, because all these vulnerabilities I just explained were the same app, okay? And then this is how it looked, right? So this was the hard-coded AES key. So you have like the AES encrypted stuff with the hard-coded key, and then you have the decrypted message, right? So you have a useless AES layer with a static key. So this is the catastrophe summary, right? So you have a phone number, you encrypt it with XOR with a hard-coded key, then you have the JSON with this like XOR in there, then you encrypt the whole JSON with AES with the second hard-coded key, and then you send the request, but the SSL warnings are being ignored. So it's the same as if you didn't have SSL, right? Because it's like proceeding with the invalid certificates, and then you get the response from the server, right? So this is like the catastrophe summary. This was all in the same app, right? So amazing. You couldn't do it better on purpose, right? So really impressive. And now let's briefly touch on some other topics, right? So task hijacking is a type of vulnerability that we find in almost every commercial mobile pen test. And basically, it allows you to mess with the task list in Android, right? So maybe I'll just, I'll briefly explain it, and then I'll show you the demo, which will make it easier to understand. So basically, you have a launch mode of single task or in the launcher activity, and then what you can do is to attack this and mess with the Android thing, right? So this was in the Leave Home Safe app, this COVID-19 contact tracing app mandated in Hong Kong, so people in Hong Kong were forced to use it. So you can see the task manager has Leave Home Safe, which was the app being loaded, right? And then when you click on the attacker app, it messes with the task list in Android, right? So first you open the victim application, and then in the task list of Android, you have Leave Home Safe, right? And then when you tap on the attacker app, it messes with the Android thing, and then if you show the Android task list, I'll just stop it there, you will see that it says Leave Home Safe, right? So this is the legitimate app, and then when you click on the attacker app, right, and now you show the open applications, you can see it says Leave Home Safe. It doesn't say attacker app anymore, right? So we are messing with the task list in Android. So what you could do is to show like an attacker app could have the login page exactly like the legitimate login page, exactly the same look as the victim application, and then the user has no way to tell, right? And then they try to go back to the app using the tag list in Android, and when they tap on it, they are on the attacker app, which has like a page that looks exactly like the legitimate page, and then they enter the credentials there, right? So a lot of bank Trojans have used this type of technique to, you know, get the user credentials of people in their bank, right? So this would be the way to fix it, to set an empty task affinity, to change this to single instance, and so on. And then this is a very interesting logic bug in the same app, the Leave Home Safe, this app, that the COVID-19 contact tracing app. So basically, I'll just show it in the demo because I still want to show you other things. So this is the application, and it basically has a setting to enable authentication to see the vaccination records, right? If you are vaccinated for COVID or not. So when you tap on this, it's going to require Touch ID, and it was the same vulnerability in Android, right? So it was in Android and iOS, but it worked on both. So if you close the app, you can go in here, and basically the attack is this type of attack that even your grandmother can do, right? So you basically just go to the settings and disable this Touch ID, and then it's not required anymore, right? So, so you tap on it, it's requiring Touch ID, and now what we're going to do is to cancel this and go to the settings, and then you go to the app settings there, you disable the authentication, and then when you go back to view the vaccination records, you are in, right? There's no prompt for the Touch ID anymore, right? So this type of logic bug would be very difficult for an automated tool to find. This is normally only found by humans, right? And yeah, this is basically the attack vector, and the way to fix it would be to require Touch ID to disable it, right? So that'll be the way to fix it, but they really didn't fix it. They just removed the feature, so it was always insecure, right? Okay, and then another interesting one was this one, this man in the middle without warnings using invalid TLS certificates. Again, in the same app, mandated in Hong Kong, right? So basically, the attack here is, so we could intercept the logging of the users, like going into the Hong Kong health system. So I'll just skip over and show you here, like using Burp, you normally have generate CA sign certificates, right? So this would be like simulating a legitimate certificate, but you could have a CA sign certificate with a specific host name. So you can put here attacker.com or whatever, and then the validation should fail, right? So if you try to open this with this configuration, this man-in-the-middle configuration of showing SSL certificates valid for 78security.com or attacker.com, then Android will complain in the browser saying, like, there are problems with the security certificate, because there are problems, right? It's not a valid certificate. But when you open the Leave Home Safe application, you could log in with your username, your password, the second factor. You could man in the middle everything, no warnings in the app, everything is fine, right? And you could also man in the middle the second factor, like everything. And yeah, this is like the code for this. This is why it works, right? So this is the vulnerable code. So in this case, the hostname verifier on Android, they were overriding it, and the verify function had this string here, right? If it contains these very important servers where people in Hong Kong logging with their health system credentials, then skip validation, return true, right? And this would be the valid validation from Android, but this would be return true, right? So this will never execute when this happens. So for these servers, it was, being skipped. Now, when I showed this at some other presentation before, this may look like sloppiness, but someone suggested that the Chinese like to implement this type of vulnerabilities, because using something like DNS rebinding, for example, from mainline China, you could man in the middle transparently users in Hong Kong and get their Hong Kong credentials this way. So maybe it was intentional, maybe not, I don't know. We just know that it was a critical vulnerability and it was found during the test, right? And the demo for this one you can see on YouTube. And yeah, let's briefly explain the API attacks, right? So I'll just show a couple. Yeah, I'll just show a couple of API attacks, because this talk would be incomplete, right, without attacking the API. So first example would be retrieving files from the server. So in this case, we had like an application that has this type of code here. It's trying to avoid path traversals like this. Can anybody see the problem with that? If you do ... and you just remove it, are you safe from path traversal or not? No? Of course not, because you can send ... and then when you remove ... from here, you end up with ... right? So you just can send to the application ... a few times, and then etc password, and then when you do this, you basically can read the etc password, right? So this was this vulnerability, which was interesting. And then this is another scenario from another app that had a parameter for the PGP fingerprint, and then it had this like run command here, and it's using shell true, which is really bad. There's lots of warnings in the Python documentation. Don't do this. Are you sure? You should never do this. But even then, people do it. So basically, this is just taking the command. So there's a string concatenation here, and basically you have remote code execution, right? So using hack vector again, so this very cool tool from Gareth Hayes. You can just go into the website. We had to encode the payload, so we could use like these special characters. And basically you send this to the vulnerable application, and then we could get a reverse shell, right? So there's a Linux reverse shell one-liner that you can do like this, and then you just send a curl command, using this PGP fingerprint and so on. And then when we got the shell, we were already root, right? So we didn't have to escalate privileges or anything. We already root, so all good, right? So, okay. And then another possibility would be API leaks, right? So what happens if you can read data from all users in the system and so on, right? So Smart Sheriff, this app that I talked about with the catastrophic summary before, had this bully API, right? So this was an application supposed to protect children. So it had an API for bullies, right? So if you are, you might remember some child like this from your childhood, right? That is, he likes to mess with everybody in the class and make their lives miserable. So this application had an API for these guys, right? So basically, if you had the phone number of a child, you could ask the API, hey, Smart Sheriff, I have this phone number for this child I want to mess with. And then the API will tell you the parent phone number. Now with this, you can already do some damage because you can call the parent and say bullshit things and make prank calls and so on. But then, you know, as the bully kid, this is kind of half of the story, right? Because like the parent phone number was the login, and then you're kind of missing the password, right? So in life, you should always ask questions, right? The worst thing that can happen is that you don't get the answer that you hope for, but when you make questions, sometimes amazing things happen, right? So you could ask, hey, Smart Sheriff, like, come on, like I'm half there, give me the password. And of course, it gave you the password with the XOR hard-coded key that I talked about before. So you could decrypt it and get the parent password, so you have the parent phone number and the password. So now from here, you can log in as the parent to the dashboard, and then you can say this child can never use the phone, cannot install any apps, cannot visit any websites, and so on. So it was really helpful for these like bully kids, right, the API. So this is why we called it the bully API. And this is kind of the bully API in action, how it looked like, and so on. And then because like everybody in Korea was forced to install this app, you can like randomly like try phone numbers, and then you would get the parent phone number and the password of the parent, which was also like 4 digits strong, right? And so on, right? So then this app had a cousin application called Smart Dream. So this looked for harmful words. Basically, it was abusing functionality intended for text-to-speech, like for blind people, right, to tell them what is there. So I'm just going to show a demo of all this like Smart Sheriff mess, right? One thing I'll touch on briefly is that we also reported an XSS, and because the report was public, Google indexed it. So you could just click on the Google result, and then the XSS would still work because they didn't fix it. So this is like when you screw up really bad, right? Like someone audits your website, the report is public, and then Google indexes your vulnerabilities, and they are there forever, and you just click on the Google result, and you can see here the XSS in action there, right? So yeah, so this is one. Then this is the one for the passwords, right? So it's basically trying like random phone numbers in Korea, and then you have the parent phone number and the password and so on. And then it's just, you know, trying phone numbers like that. So I'm just going to skip a little bit ahead. Like here, right? So it's basically trying like random numbers and so on. And then you get, you know, parent phone numbers and passwords and so on, right? And then the last one would be Smart Dream, right? So Smart Dream was looking for harmful words, right? So the idea is if the child types to someone else with a text message, Kakao Talk, which is a popular thing there in Korea, or something else, if it contained words like sex, alcohol, or whatever, then it would get flagged like it has a harmful word, and then this message would get stored in the API, right? So what we found was you could call this API and dump all these messages from all these children that were flagged with harmful words, and you can see like the phone number of the child and the message that got flagged and so on. And now Fabian, who is the one who put this together, he actually replaced the Korean characters with random ones, but probably here nobody speaks Korean, so you don't notice. But yeah, you know, like to protect the privacy of these children and so on. But basically that's the idea, right? So you could like call the API and download everything from everybody, right? So all the messages and so on. So, so yeah, so that is that demo. And with that, just a reminder that you have, if you are interested in the slides and download the vulnerable apps that I demonstrated and so on, it's all free in there, and that will give you access to the slides, the vulnerable apps, and everything else. The Google Summer of Code, if anybody's interested in working for some OWASP project, Google will pay you, right? So you can send your proposal to Google. There's this OWASP project, but there's also other OWASP projects. If you want to connect or hit me up, feel free. And now, I don't know if I can take any questions.
Okay, let's give a round of applause for our speaker today.
Thank you.
Are you going to be around for a while after?
Yeah.
We'll probably just have questions if you want to approach Abraham afterwards, because we're running a little low on time. So let's give another round of applause. Thank you.
Thank you.
Well, not really, not yet. Gotta get my presentation up here. Awesome. Let me know when you guys are ready.
Okay, awesome. Our next speaker is here to talk to us about North Dakota SOC and automation in cybersecurity. North Dakota has a world-class SOC, and Jaden Evanger has been working for NDIT for about 8 years?
The state for over 7 years.
Over 7 years. So a wide range of experience, and it sounds like a lot of valuable information and insight for us about cybersecurity and automation and North Dakota SOC. So thank you.
Thank you very much. Well, how are you all doing today? Good. Are we ready to talk about some automation? Yeah? Awesome. So yeah, like I said, I'm Jaden Evanger. I'm a senior cybersecurity automation engineer with North Dakota Information Technology Department. And I will go over a little bit what NDIT is. Has anybody heard of North Dakota Information Technology in here? Few of us? That's actually pretty good. We're in South Dakota, so we're a little out of the territory. So North Dakota Information Technology, we're kind of like the central IT agency. We do all the networking for all the state entities. That could be like state agencies, K-12 schools, even some of higher ed. Higher ed's on our network as well. In North Dakota, there's political subdivisions, which are cities, counties, and there's even a tribal nation as well, and boards and commissions and things like that that are on our network. We're securing those. We're helping those agencies out with a lot of technical support. So that's kind of what we do at a very 10,000-foot view at NDIT. So why do we have a heavy focus on SOC automation? So what I will start out with here is we've got a lot on our network. And we've got probably over 250,000 people on our network, like during the peak of the day. And at any one time, we could probably have either from 250,000 to 400,000 devices on the network, depending on which statistic you look at. So there's a lot of devices on the network, and we don't have that many analysts, if you really think about it, because we got our EDR solution deployed to like 80,000 of those, and of those 80,000, we've got like 3,000 endpoints per analyst, something like that. I don't know the exact numbers, but it's somewhere close to there. So automation is super important because we've got too much. Now, we would never be able to automate out all the skill sets that we have on the SOC. We've got some very talented people doing incident response, and we're definitely not trying to replace their big talent, but we need to scale those people so that their talents are put to good use. So that's kind of our goal. And then the SOC before automation, we had a SIM. That SIM was very delayed. You would have alerts coming in, and then you wouldn't see them to be actionable on them until the next day. So you could have like up to 24 hours behind on alerts. That's pretty bad, right? Because when you've got potential attacks coming in and things like that, you really need to act on those right away. That's really the ideal. And then phishing email reports, we got a little thing in our email client. You can say, hey, I think this is phishing. And we had that before automation as well. And we had analysts working those manually. They were going through DKIM, DMARC, attachments, running those through VirusTotal or something like that. And it was a nightmare having all of that before automation. All the phishing emails that were ever reported were looked at manually. That's pretty bad. Lots of work. It was chaos. And then, of course, we've got tedious tasks that analysts are doing, like sending emails to customers. If there's like an external IP exposed from an endpoint on the network or something like that. Putting in tickets to the network team to block IPs and domains. So all that stuff was done manually. And we have very little automated reporting. So let's say the CISO wants to figure out some statistic like how are we doing as far as closing incidents, and how many are false positives, how many are true positives, all those kind of metrics. And we didn't have any kind of automated reporting for that. So manual reports were being built for that kind of stuff. Nah, not so good. We want to be able to see that stuff in real time or near real time. So when we started embracing automation, we've got a couple of statistics here. Of course, these are not comprehensive. There's a lot of other statistics that we could pull or might be a little bit difficult to pull, to be completely honest with you. But phishing reports that we get in, we've got over like year to date from January 1 to July 20th of 24. These slides are a little older, you gotta forgive me. In that time, that's like half a year, we got 20,453 reported emails from our end users. And we closed 57% of those completely hands off from analysts. That's quite a reduction of workload. And then Cortex XDR, that is our EDR solution that we have deployed. Works with our firewalls too. We have incidents that get generated from those. And we actually tune out a lot of those alerts at the EDR level in the console. So we're only looking at what the automation is seeing. And we got 5,323 in that same time frame, about 6 months. And we closed about 47% of those completely hands off from analysts. So where did we kind of start to achieve this? This was probably like 4 years ago or so, but we started off, and these bullet points are not in a particular order, by the way, but we start building a team of automation engineers. So you can kind of think of an automation engineer, that's what I am, is kind of a cross between a software engineer and a security engineer. Some might say that is a security engineer. Of course, there's a lot of ambiguity of titles in the industry nowadays, so don't get too caught up in titles. I know that's hard to do sometimes, but this is the kind of talent, that kind of software engineer first type of skill set is really what we need for a lot of our automation engineers, and that's the kind of talent that we seek out when we recruit. And of course, shameless plug, we are looking for a senior engineer right now. I'll mention that again at the end, and if anybody has any questions, come talk to me. But yeah, that's the kind of skill set we need to build out our team. Then we chose to buy the Palo Alto Cortex XSOAR, and I'm going to get my little laser pointer out here. I think you guys can see that, can't you? So that's the logo for Palo Alto Cortex XSOAR. How many of you have heard of XSOAR? Couple? Awesome. How many of you have heard of SOAR? Just any SOAR product. Okay, a few more hands. Perfect. So yeah, we decided to buy XSOAR. It was called Demisto at the time when we bought it. That was actually before I started on the team too. And then we started to build out some SOC automation with the Palo Alto Networks consultants. And we still have some of those consultants today that started with us. They are absolutely tremendous people. They helped us so much over the years. And then we shadow the experts. So when I say experts, I mean the people who are actually experts in incident response. Because a lot of us who kind of have that software development infrastructure background, maybe we don't have some of the incident response experience, but we actually did Gemba walks where we were, that was a concept first started by Toyota. And we basically do a shadow with our analysts to figure out what are they looking for when they're investigating these incidents, right? So that was really important to us, and it helped us build our automated workflows for incident response. So what does the team look like? So if you look at these blue boxes here, that's the automation engineering team. We got a manager here, the team lead, that's actually a lead of 2 other teams, red team and threat intelligence, which is under the, cyber active defense team over here. Then we got a principal engineer who's kind of like a scrum master. So like I said, we do kind of have a software team kind of focus on our team. So we actually do have a scrum master. That person happens to be our principal engineer. Helps keep things organized and moving for us engineers that are really in the weeds, technically speaking. We got senior automation engineers. I am one of those. We are recruiting for another one right now. And these people run a lot of the bigger projects, the big migrations, the big, bad, ugly stuff, right? And then we have 4 tier 1 automation engineers. Those are the people who are really boots on ground, that are there doing a bulk of the development work. That's not like big project kind of stuff, basically. Then we got some stakeholder teams that are in amber color on the outside. These are teams that are in our SOC or in our GRC side. And this is who we're building the automation for, because we're trying to make the lives of these people easier. Then we also do some stuff for our network engineering team too, which is not pictured here. So I'm going to go over this slide really quickly. I'm not going to go over all this stuff, but we do, like I said, we have a Scrum Master. We've got a modified Agile Scrum process that we have. We are not Scrum by the book. I'm not sure if anybody is, but we do Scrum to a certain extent. So we've got kind of a process where our internal people can submit requests saying, hey, I'd really love to be able to do something like this. We want to automate this. This is really a pain point. Takes months of our time a year. We feel like this could be easily automated by your team. We take it through this process. We do, excuse me, we do architecture, design of those solutions, and testing, put into production, right? Your typical SDLC, even though maybe it's not your typical software development that we're working with, because we're working with a lot of SOAR tools and security tools, as well as like web applications and stuff that we have internally. So we'll kind of go over the concept of XOR. Not sure if you guys can see that super good, all the stuff on there, but we've got kind of 4 different main pillars of SOAR. So we got the automation and orchestration stuff. That's kind of your main component that literally does your playbook running and running your Python code that you've got inside the SOAR solution to collect data, enrich your IOCs, things like that. Then you got real-time collaboration. So if you want to collaborate between analysts on a specific incident, that's kind of what that pillar stands for. Case management. You're actually able to hook into APIs for like ticketing systems and things like that. And you can communicate with end user customers through your incident, and it can actually mirror messages and stuff and notes on tickets that people submit through the service desk. So that's pretty cool. We definitely have used a lot of this in the past. And then we have threat intel management, last but not least. That pillar is for basically holding a huge database of IOCs, or they're not necessarily all IOCs, but they are indicators that we can enrich and keep basically a huge cache on. Like, do we know that this is malicious based on our threat intel sources? So we've had 3 million indicators at any one time inside of this. So you can get it to be absolutely massive. So the version that we are currently on with XOR is XOR 8. There is an XOR 6. They skipped XOR 7. So, and what this basically is kind of like an architectural diagram, 10,000 foot view on the XOR 8 infrastructure. So we've got the marketplace where you've got pre-built by Palo Alto, and we've actually contributed some things to the GitHub repository as well for content that's used to connect out to external services. A lot of vendors that build stuff, like I'll use an example, ServiceNow. What they will do is they'll come in and they'll use the SDK and everything for XOR. They'll build an integration. They'll build content like playbook automation. They'll make that available to anybody who has the product to use in there. So you have to write a lot less code yourself and a lot fewer automations and things like that. So it all runs in a K cluster in Google Cloud Platform, and the actual playbooks and stuff run inside of here. There's kind of an automation engine that's in the cloud, and it all scales. It's all K8s cluster kind of stuff. You got Google BigQuery, Redis, MySQL, all back there. And then you've got an XOR engine. So this is kind of like a miniature version of this automation engine for scripts and integrations that talk out to external services. And what this engine will do is it actually sits inside your network. And if you've got services, which we do have a couple, that reside internally that don't expose themselves to the outside, you can actually write your integrations to talk internally on your network, and it will phone back home the results. So you can hit all kinds of APIs internally that are not exposed from the engine. Pretty cool stuff. Then you got the playbooks, which are kind of like a workflow language. It kind of looks like a low-code, no-code solution, and I would say that is a not bad description, although if you do want to get a lot out of the product, you definitely have to write a lot of code. I mean, most low-code, no-code solutions oftentimes have a lot of code. That just is the way it is. You never have a one-size-fits-all solution. That's part of the reason why we have jobs. Then you can actually see the playbook running in here. I got a little animation there. But yeah, with these little tasks that you see in the workflow, you've got like a manual task that you have an analyst look at manually and say, yes, this was malicious, no, it's not. And then it can pick different branches on the path and do different logic accordingly. You can actually send out emails to users saying, hey, did you click the link in this email that you reported? So you can do some automation like that that cuts down on some of the communication flow that an analyst has to do with the end user. Saves a lot of time there because the user can just do it themselves. And then you can run scripts. So it's mainly Python. There are ways to run PowerShell and JavaScript. JavaScript's kind of on its way out in XOR, but PowerShell, if you need to do like commandlets with Microsoft services, and it's mostly like 99% Python that you want to do inside of XOR. Then you've got your context data, which you can't see on the screen, but every time a task runs, and it runs an integration command, which is basically some usually Python code that talks out to an external API, or you have some kind of an automation script that's wrangling some data, changing the format, enriching things of that nature. The outputs of that are outputted to some kind of like JSON blob that's kept with every single incident. And then that can be modified by the playbook as it runs, and it's kind of like a temporary storage place that those tasks can dump whatever results that they have. So let's go into kind of what we were able to build and what we were able to automate as a automation team working with the experts inside of our area. So we got the phishing reports and phishing investigations. So like I said, we've got a little button where you can say, hey, I think this might be phishing. And then what we do is we actually do a lot of automation there to try to figure out if it's malicious, if it's spam, or if it's legit. So kind of the workflow is the user reports and the XOR system ingests the email, creates the incident. We parse all the email headers out and attachments, and we send the survey to the reporting user so they can say, yes, I clicked the link, no, I didn't. I opened the attachment, no, I didn't. And then we rasterize the attachments, so like a PDF. That way our analysts don't have to open the PDF themselves. We actually have automation in here that can rasterize that for you. It's pretty cool. And then we check for some duplicates. If there was other users that already reported it, like an actual phishing campaign going out to a bunch of users, we extract the hyperlinks that are in the email. And then we have kind of the cool part, the machine learning, some of the AI coolness that we have to make some predictions on what that email might be, if it's spam, malicious, or legit. Then we do kind of a severity score matrix, and we auto-close if we meet the right criteria. So we kind of go over a little bit of the phishing machine learning here. We train our machine learning model, so this is like a text-based model. We use something called fast text in here. It was actually originally created by Facebook. That's kind of the AI model that gets trained and run in there. And we actually train the model in-house automatically. So we take what we have is basically tag data, because we've got a bunch of emails from the past that analysts have manually classified in one of those three categories, which is what we would call classes in the AI world in machine learning. So we do about 5,000 to 7,000 previous emails every 7 days, and we use that to train a new model on basically new and updated data. So we're trying to keep the model as accurate as possible with upcoming trends for new emails that might be coming in, different types of phishing campaigns, things like that. So then we do some pre-processing. When we make a prediction on an email, we strip out the banner that says, oh, this is from an external source, because that's pretty redundant. We don't want to cloud up our machine learning training with that. So then we do some text pre-processing. So I'll give you some examples of this at a high level. If you've got email addresses or like social security numbers in the email, which probably shouldn't have in most cases anyway, but if they are in there, you'll actually replace those values with like a placeholder value. That way you're not introducing a bunch of differences that we would have to parse out when we're training the model later. Keeps it consistent, keeps the training data consistent. Then we train the new model, and that fast text basically makes a Huffman tree. That's kind of like the data structure that it has, and it's like a softmax type of activation function. I'm not super well versed in the mathematics of ML, but I did look into this a little bit, and it basically builds out a tree. This is not your typical, what you might think of as deep learning. That would take too much resources to run on the server side. So we have this fast text model, which is actually very accurate when you would compare it to like deep learning. It gets almost, from what I hear, almost as accurate as like a deep learning neural net, even though this is like a very basic neural net, if it even is a neural net. And then we actually run it on like one CPU core. We run this inside of Docker containers, because all of the automations and stuff are actually ran in a Docker container. And those are all by default pinned to one core. And it's got like a gig or up to like 3 gigs of RAM or something like that on the server side, usually like 1. So we don't have that many resources when we're training and making inferences on this data. So we need something that's pretty lean, and that's what Palo Alto provided, was a model like this that we could use. And then the other really cool thing that we've been able to do with XSOAR is automating our firewall upgrades. So what I'll say is that our network is massive by most people's standards, and we've got, I think, over 140 next generation firewalls in our environment. So it's a very large firewall deployment. We got a large firewall fleet, and it takes our network engineers a lot of time to go through and make sure that those are up to date. So we did some automation here. One of our contractors from Palo really helped us get this going. But yeah, so what this does is our networking team creates a change request in our ticketing system. Then we take a snapshot of the firewall, because what's the first thing you do before you upgrade a firewall? You probably want to take a snapshot so you can roll back, because that is the manual procedure that they do. So we actually automate that. We store inside of the incident in XOR the snapshots of the firewall through the different reboots that you have to do of the firewall. And then, by the way, the incidents in XOR don't have to be for an actual security incident. It can be for other automation too. So these are all running inside of incidents in the system. So they're very versatile that way. So after we take the snapshots, we start the firewall upgrade, we install the new software on the device, and then we reboot the device. And I got a little loop here in the workflow because a lot of times it actually takes multiple reboots to get the software level up to where you want to be from where you were. And this playbook here will actually keep track of all that. It'll get the status from the device. It's like, hey, are you back? I keep polling as you're rebooting. Are you back? Are you back? Are you back? Once you're back, then we're going to start loading the next image, and then we're going to reboot again. So then we do post verifications where we check things like, are BGP sessions going up? Are things trending in the right direction as far as session counts and things like that? Because if it's not, then it will actually kick a ticket to our network engineering team so that they can take a look. Because if sessions and BGP are not building back up after you get the firewall back up and running, that's probably not a good sign. Either it was a software bug or something just happened that takes routing down. No bueno. And then this actually also supports high availability pair of firewalls. Because usually with the high availability pair of firewalls, you upgrade one, then you switch the routing over to the other one, and then you upgrade the other one. This actually does that automatically. So that was really cool. Then we have a system that we call SecIntel. So this is a homegrown system of ours. It's a web application. It's got a bunch of cron jobs on it. Cron jobs run the world, am I right? So we got a bunch of contact and entity management. So we got a lot of customers on our network. I think if you count all the agencies, even the ones that might be under another agency in the hierarchy, we got like 300 and some customers inside this system. And we keep track of who do we contact if the analysts need to know who to contact from the agency, from like a risk perspective, or if there's an incident or something like that. We store that in here, and then we actually have an API that exposes this, and XOR relies heavily on this when we enrich like IP ranges and stuff. We actually store a bunch of IP ranges from our IPAM solution, and we hook those and associate them to where the IP belongs, like which of our contacts does this belong to. And then, of course, users, we know based on where they're at in the directory structure, we know where they're at. So when XOR gets these indicators from incidents like, oh, this user had this happen on that machine, now we can go out, hit the API of our internal system, and now we can get a bunch more intelligence on how to respond. And it's not something where the analyst is kind of trying to figure out where stuff's at, spending precious time doing those things. Then we do some red team application scan management too. We schedule vulnerability scans, network scans with the cron jobs in this system. There's a lot that we do here. And this is all custom development. This is not from a vendor. We built this in-house. So we can see here a couple of examples. I got some redacted out pictures here, but we've got the significant technologies database is what we call it. So our threat intel team can enter in systems that we know are significant on our network, and we can keep track of those so that we're not calling the same people over and over saying, hey, do we know that we have this on the network or something like that? And then we've got our contact management, which is arguably the biggest part of the system on the right-hand side here. So this is what we see. Yeah, the interface doesn't look pretty. It's all Bootstrap, CSS, but we don't care. It's pretty cool. You know, most of our SOC analysts, if not all, they like it, even though it might look ugly. So we've got a bunch of other automation. I don't have time to go through all this stuff, but this is kind of some of the other stuff that we were able to build with either our SecIntel system or the SOAR platform, XSOAR, that I talked about earlier. So what are some of the issues that we face? Because we've got a lot of stuff going on here, a lot of automation. We've got 6 people plus 3 contractors to help maintain all this stuff. There's got to be some stuff that goes wrong, right? And you'd be correct, there is. So in XSOAR, we've got huge, hard to maintain playbooks. I don't know how this dark theme, like I'm a dark theme person. I can't do light theme. Not sure how it shows up on there. But you can see there's like hundreds of tasks. And like I think this one is our phishing playbook, and it has 771 tasks in the workflow. If you look at all the sub playbooks and every task that it could possibly go through, we got 771. That's a lot of tasks. So this makes maintaining this stuff kind of difficult. Makes testing kind of difficult when we got to run through all these tasks when we try to make a change and run through and do some regression testing before we set it to live. Not always the most fun thing. And we also have a lot of code too. If you don't count playbooks as code, which they kind of are, they're just not Turing complete. But we've got 29,052 lines of code currently in XSOAR, and that's all the custom content. That does not count the code that the vendor has provided. So this is all the stuff that we did to customize the system. And we have almost 17,000 lines of code of Python for the SecIntel system, and 2,450 playbook tasks in XSOAR. So that is a lot to maintain for 6 plus 3 people. And go to the next one here. And of course, that means we have bugs. We have regressions when we start promoting this stuff to production. And in 2024, as of September of 24, we have 129 bugs, so that's year-to-date, 2024. And we've closed, resolved somehow, or, oh, we don't need this anymore, kind of a thing, 119. So you might think, okay, we closed most of the bugs. That's good, right? Well, not really, because there's too many bugs there. You can see features we're actually lacking behind here on the rate that we burn down of actual features that are going to be instrumental to increasing the success of the SOC. So features is where we really want to focus. Bugs, they're a nuisance. We need bug spray. So the engineering effort, you can see it's actually just a hair more of a percentage that we spend on engineering effort for bugs versus features. Bugs is red, features is blue. So this is not a good thing, generally speaking. Our target would be to have like this much be features and only like a sliver like that of the pie be bugs. So we're spending a lot of our time and effort on bugs where that can be fixed. But then how do we fix it? So one way we can do that is with code reviews and standards. We didn't have a whole lot of that when we started a lot of these efforts, but we have developed Python standards for integrations and automations within XOR. And of course, we do some of that with the second Intel system too, but most of those standards are for the SOAR platform. That's where most of our work goes. And we have code reviews, and we actually set up a CI/CD pipeline for this as well. So we're not just pushing and pulling into prod. We're actually able to do a full code review. You can see that happening here on the left. And then when you merge it into main, then it deploys out to the source solution, bada bing, bada boom, you're good. Then you got some of the standards that we have in our documentation that really help our engineers kind of stay the course when it comes to what do we not want to do from a reliability standpoint. We're not really focusing too terribly much on do you have the correct syntax. This is more like conventions of how do you call a command in the system and how do you do the error handling if that fails. Things of that nature. That's what we really want to do. And then we implemented some linting using our SDK that the vendor provides. We do rough and MyPy type checking, and that seems to help quite a bit too, although it's a real pain when you run that on an old code base. So just a pro tip for everybody here, if you're starting a project in Python, especially if it's like a web app and not a SOAR solution, get your linting and type checking in there early, not later. It'll save you a lot of headache down the road. And we have architectural oversight. So the senior tier of engineers on our team, kind of one of our new-ish responsibilities is kind of working with the stakeholders, our internal customers a lot more to understand what's actually their requirements, making sure that we're not duplicating efforts so terribly bad and having one automation that does almost the same thing as another when we maybe can consolidate those things. So that from an architectural perspective is something we're really interested in getting better at, and we certainly have. And then guiding our engineers through the development process, being kind of that mentor. And then of course developing new standards for the developers to follow to make more reliable software and automation for our team. And just trying to decrease technical debt as we go. Of course, that's not possible. Sometimes there's timelines that we need to meet where it's not possible to eliminate all technical debt. There might be oversights that we look back later and it's like, oh, we really should have done it this way. We've learned more since then. That's always going to happen. But we want to decrease the amount of that technical debt that's coming. And then, of course, we actually are switching to a new source solution. I left this until the end because this is really cool. So Palo Alto Networks came out with a new product called XIAM, so that's spelled X-S-I-A-M. Have any of you guys heard of XIAM out here? They've been doing a lot of marketing campaigns and stuff. It's really cool stuff. So basically what it's doing is it's taking XOR and it's putting a lot of its components into that Cortex XDR-like solution. And then you've got new stuff like Jupyter Notebooks, where you can start hitting the BigQuery database and doing some big data type of analysis and threat hunting using big data that you have with all the log sources coming into XIM, because it's also like a SIM solution too. It's like an all-in-one solution. So we're currently, ever since like November of last year, we've been porting over everything from XOR that we've done in the last 3 to 4 years and redesigning it to have a little bit of a better, simpler architecture where we can, and bringing that into XIM. So there's a lot of really cool stuff that we can do with this, and it's reducing a lot of the complexity that we had. Like we had playbooks with hundreds of tasks, and now it's a fraction of that in a lot of our playbooks that we're developing now. So of course, with any migration, there's challenges that we're going to face as we're redesigning and re-implementing everything that we've built, but we're getting through it pretty well. And who knows, maybe I'll have another presentation on how that migration went. Any questions? I think maybe we should give you a mic. Sorry about that.
And I'll come to you, and if whoever else has questions, if you guys want to come to the front, that might make it a little more streamlined.
So you had that slide of the number of lines of code that you had for the various integrations, and then you moving from XOR to XIM. How much effort, and from a time perspective, was it to build it, and how much do you think it's going to be to convert it? And then a second question to that would be, technology is constantly evolving, so the next version, are you going to have to rebuild those automations each time, or is that something you anticipate?
Yeah, so to answer your first question about the lines of code in XOR, 29,000 today, it's going to be a fraction of that inside of XIM, because we're going with a playbook first approach. We're trying not to write so much code this time around. We're trying to utilize the platform features as much as we possibly can. Of course, there's going to be cases where we can't do that. We're going to have to custom roll some code. But as far as like the time to get it done, it's actually really hard to estimate, just like any software conversion project or a greenfielding type of development. But you know, hopefully we'll finish sometime this summer with most of it. So it would be at least a 6 to 8 month project, probably, to do it all. And then your next question on, are we going to have to do this whole migration again with some new technology? And that's absolutely possible, because sometimes the vendor might not give you a clear path of migration with a new product or a new product iteration, or they might change the whole philosophy on how the product is supposed to work, which is kind of what the deal is here with XIM. It's a bit of a different philosophy. So whenever you've got a different philosophy, you're almost always going to have to rebuild stuff. Did I answer your question? Okay. Good questions.
I had a quick question. So you talked about automated phishing closing. So closing some of those with your AI solutions and stuff. So I was wondering what the criteria was that you're using for automated closing. So is there a certain limit, or how do you know that this was truly phishing, or you went through and checked it?
Yeah, I don't think I can actually discuss all those details. But maybe I can talk to you offline later about that. But what I can tell you is that we do things somewhat based on reputation. That's a part of the scoring matrix that we have. It might, raise a score if something is known malicious, like an IOC. But there's some other factors too that I don't believe I can disclose here. And then of course we got the machine learning verdicts that come out. So, yeah, great question.
Yeah, from the time that you got onboarded with the playbooks, and then your employee and your staff at your SOC, what did that mean time to onboard your employees? So say you get a new employee, you got all these playbooks, I mean, it should just be pretty quickly. And then did that also assist in reducing your attrition rate? Like how often? Because sometimes some SOCs, it's trial by fire, and people are just wave after wave after wave and just inundated. And if it's limited and streamlined, hopefully that makes the longevity of their employment a little bit better. So I don't know if you can speak.
Yeah, so just to follow up with that question, do you mean the mean time to train up an employee? Do you mean the engineer or the SOC analyst?
The SOC.
The SOC analyst? Yeah, I don't know exactly, but based on what I have seen, they've been pretty quick to catch on. Like, for sure within 6 months, they're providing a lot of value from what I see. Now, I'm not the manager of the SOC, so I wouldn't be able to give you an exact figure on that, but I would assume, from what I know, that it has improved since we brought on the automation for getting people up to speed. And then attrition rates in the SOC, I haven't seen too much. You know, we have a lot of excellent people, and we keep them for a long time.
Going into that, the residual cost then, or savings for the implementing the playbooks and XIM, and then how long those employees, does that also get presented? Like to say, hey, this is how much, look at, we used to run through employees like crazy, now we're saving them so there's no more recruiting, all those other costs.
Yeah, so actually some of our consultants with Palo Alto, they compile some of those stats like every quarter or every half year. And I can't remember off the top of my head, I don't have it handy here, but it was a significant amount of hours. Like, I think it was actually, well, don't quote me on this, but it was probably like at least one FTE's worth of time that was saved with a lot of this.
What other questions do you guys have?
Hello.
Hi.
Yeah, since your tool is automation heavy, so how are you tracking false negative or false positive on the detection?
For the phishing stuff, you mean?
Yeah, for the alerts, SOC alerts.
Oh, sorry, I didn't quite understand.
Okay, so like how are you tracking the false positive on the detection of the incidents? So
Yes. So we track false positives and true positives on the ones that are manually worked by analysts, and for the ones that we are closing automatically, we actually have a calculation that we can do with known good testing data where we got like an 80-20 split where we train the model, and we can actually tell what its approximate accuracy is as far as like false positive versus true positive flagging. Does that kind of answer your question?
yeah.
Okay. Thank you.
Good afternoon. Great presentation. Thank you. If you're able to say, you said prior to automation you were using a SIM. Are you able to share which one you were using? And then with regards to logging from that SIM going to the previous iteration to the XIM, can you talk a little bit about what you're seeing with the logs that you're maintaining, and what kind of gains that you've received through that as you've transitioned as well?
Yeah, I think we were running like a Juniper SIM prior. However, I was not actually here in the SOC when we did the transition of logging to the new, so we put it over to XSIM is what it was called on the Palo Alto side, I believe, before it turned to XDR and then XIM. But what I can say is that we've never had the performance issues that we had with the old solution. So we were never behind on logs coming in, and the language that we can use to parse out logs and make a nice parse log from the raw log, the XQL is really good language to work with. It's very flexible as far as parsing out logs. So I don't know, I'm not on the logging side of things, I'm really only automation, but that is what I know. Did I kind of answer your question a little bit? Okay, cool. All right, anything else? Awesome. Thank you very much, everybody.
Thank
Have
you.
a great day.